Well, it's very fascinating, living on inspiration more than anything else, letting the imagination go wild. I was taking a walk and I had the thought come to me that what if Tesla was giving us a riddle when he said for every 200 pounds of iron added to the device, 1 horsepower output is increased, according to William Lyne, quoted in his book Pentagon Aliens, or Space Aliens from the Pentagon, the older edition. What if that's a riddle? What if it's not intended to be taken simplistically? What if it's a more sophisticated... It's an excerpt from a more sophisticated thought. You know, lawyers do it all the time. They drop something dangling off. I'll give you an example. The war between the states, we call it the Civil War. Civil, well, let's see. It doesn't mean it's between us. It just means the civil aspect of legalese. Actually, war between the states is between the states and their federal government, and the federal government won, and the states lost. So that's what the war between the states actually means. So sometimes things don't always mean what we think they mean because there's stuff that's missing. Dangling participles or whatever that dangling modifiers that changes the whole thing. Well, what if? Because I was thinking about, okay, let's turn... And William Lyne says something else in the Paul Scarzo interview. He says that aluminum will gain significance to displace iron. And so, okay, well, what is iron? What do we normally do with iron? We put it in the core of an electromagnet if it's not an air core magnet, if it's low frequency. So I thought, what if we turn the thing around? I had thought already in the past, turn it around inside out. And so now the hull of the ship, the chassis of the device, is iron, and that's somehow significant. But I still didn't get the riddle. So here it is. It's the construction, a new style of construction for an electromagnet in which the wire is iron. And so the more iron you add translates to its code, secret code for the more windings, because they are iron wire. Enameled, you can get enameled floral wire, which is iron. And I've used it in all my biocircuits because it was insulated and it was iron. And it extends the magnetic field of the chakras when you connect it to the body along the entire length of that wire. And I would put a magnet at one end, neos, a whole stack of neos at one end of that wire attached, or actually one wrap of the wire around those neos. And I had 2 groups or 3 groups of neos, and I had the middle group turned around opposite, and I forced it together. They were ring neos, donut shaped, and I had them on a skewer, a bamboo skewer, on the inside of a PVC pipe with caps, end caps, glued together, wrapped in bubble wrap. But I had mu metal, mu shielding. It's a type of magnetic shielding which is more powerful than iron, wrapped around the middle of the neos and around the outside of the PVC pipe. And then I had attached a piece of iron wire, the steel iron enameled floral wire, and I ran it a long length, or it might have been galvanized, I can't remember, galvanized, anyway, iron wire, could be galvanized steel. And then I put a compass at the far end, several yards, let's say 10 feet long piece of wire. And the compass showed deflection, showing that the magnetic field, showing what they'd said on lessemf.com, that magnetic shielding cannot shield you from the magnetic field. All it can do is reshape the field, because it soaks it up and it carries it along the length of the iron, and it re-emits out the edges, what we've learned from ferrofluid videos on YouTube. It comes out the edges and not the plain surfaces, the smooth surfaces. Actually, those are lull points where there's no magnetic field emitted as registered. It's low. Nadir. But the zenith of emission is at the edges of a piece of the iron that's reshaping this magnetic field. So that's what you do. You reshape the magnetic field when you use magnetic shielding. That's all you're doing. So if iron can carry a magnetic field extended as far as you want to take the iron, it's a very significant item of interest. But the weirdness... Oh, and then we add one more thing. Well, there's several little clues. William Lyne in that interview says that the Navy... You see, he kind of mixes storylines, so it gets a little confusing. He mentions that since the winding is a very long winding, several miles long or something, hundreds of miles, I don't know, it's a very long, 50 miles long winding or something, it's a very long wavelength, and it's a very, so consequently a very low frequency. And I think he said the ELF or something, and the Navy also uses that band for communications, which implies that they're sending the power, not generating it on board. These top secret, triple top secret Navy subs that are supposedly nuclear subs. Well, maybe that's, a euphemism, legalese euphemism for quantum mechanical, Tesla style. Not nuclear at all, unless it's a backup plan. Plan B is to turn it over to the nuclear generators. So we've got William Lyne saying it's a very long winding, okay? Which would imply that the more you add, if it's made of iron wire, the more horsepower you get because it's a lower frequency. So it's a double use riddle. Not only is it an electromagnet turned inside out in terms of its materials of construction, but he gave us the clue and said that it's a low frequency device. It's not a high frequency device, because the more iron you add in terms of windings, the more horsepower you add to the output. So now there's somebody on Energetic Forum actually getting some responses again. I used to get it in the beginning, and it didn't seem to lead to anything fruitful. And then it died off, and I'm the only one replying to myself on the Tesla special trimetal generator thread on Energetic Forum. So it kind of got boring, because, how much can I inspire myself? A little, once in a while, and it may sound goofy, some of the stuff I say, because it's all inspiration, because we got so little to work with here, so little to come up with, to try to figure out what this thing is. And I'll put out anything that sounds plausible. I don't care, See if it leads to anything. So I was taking this walk, and I was thinking to myself, okay, maybe it's time to make a proof of concept device. What would I use? I would use the latest proof of concept, in which I had an aluminum plate sandwiched with a copper plate soldered together in the gap between the two ends of a C magnet. And the C magnet would have a coil of wire, and I'd have a capacitor on that wire, and then the load comes off in parallel on either side of the capacitor, so I have myself a tank circuit, and maybe that's what I would work with. And I thought to myself, okay, well, how do I do this? Wait a minute, isn't that... Then I had a guy, Machinate Machine New 2 or something, he's brought up iron aluminum diodes. This is cool. So I had just done the video on DC lens magnetic field, dragging the electric or vice versa if it's a DC situation. And he lent credibility, and then he responded, and he came up with a copper iron situation. The webpage had to do with thermocouple, which is interesting in itself when we bring in electrochemistry, because it may hint at the kind of principles of electricity that we're looking for, even though it's chemistry, but it's electrochemistry. And so that being exothermic, that, well, actually, was it exothermic or it was both? Ew. So it had to do with the direction. Oh shoot! I'm gonna have to relook at that. I may be mistaken how I responded to that post. Anyway, so the idea is, well, what if we take these two discs that are sandwiched together? And I was thinking to myself, okay, I go to if I got supplies, what I get? Well, I get iron nails for the core of this magnet, and maybe I dig up my enameled iron floral wire and wrap it around the iron core, so it would be solid iron. And then I go get aluminum slugs from the hardware store and copper-clad pennies from the bank, and alternately stack them and make a long a long column of these stacked alternating pieces of metal. Sandwich them together under pressure of masking tape, because my soldering skills are zero. I'd more likely burn the house down than solder anything together, or create very toxic fumes. Burn everything else up. And then put that in the middle of this C magnet. And then I thought, okay, if it gets longer and longer, basically it's hardly a C anymore. You've just got this iron post of a sequence of nails running alongside it with winding around it, trying to meet up with the two ends of the copper aluminum stack column. And then I thought to myself, well, wait a minute. If it's going to be that ridiculously shaped, why not take the winding off of the iron nails and put it around the stack? And that's when I realized the riddle. Because the core is something other than iron. Let's assume for the moment it's a stack of alternating sandwiched layers of thin little plates of aluminum and copper. So you've got a core, and they have to be stacked, because there is such a thing as copper-clad aluminum wire, which would not be the same geometry. So we have a diodic stack of alternating layers of aluminum and copper. And it's not what I thought I would do, because I thought the guy's suggestion was pertinent, in which the iron-aluminum diode means that iron is going to be the reference if the magnetic field and the electric field are in sync, and the aluminum now tweaks it out of sync, so it's got a reference. But maybe it'll still work, because the iron winding is the reference. In any case, so we've got this stack, this column-shaped stack, which is the core of the winding. And then we got the winding coil itself made out of insulated iron wire, which you can get. I mean, you can get all kinds of things. You can get insulated aluminum wire, for that matter. It's very interesting what you can get these days for a price. So now we've simply got a redesigned feature in which... What is that? Is that a transformer? Is this the beginning? So your laminates are no longer parallel to the shape of the core, but perpendicular to it. So if you had a toroidal core, let's say, a new transformer construction, the laminates are at right angles to the toroid. The circularity. So the surface of the laminates are radial. If we, referenced the center of the toroid, the center of gravity, let's say, or the center of the shape, the center of the geometry, the laminate, the laminate surfaces are now radial because they're at right angles, they're perpendicular to the toroid itself. But the windings are in parallel to the surface of the laminates, which might be significant. And I guess preferentially it should be similar to magnetic wire, in which the enamel on that iron wire should be ridiculously thin as possible, to not create too much spacing on the wires winding, because we're going to add weight. So this is not the true Tesla coil that was it Josh Polensky, if I'm saying his name right, did a presentation at was it the 2015 or the 2014? no, it was the 2014 summer conference in Idaho, in which he said the true Tesla coil, you have spacing between each winding, each wrap. And so what Eric Dollard and Josh would do is create a wooden armature to create the necessary spacing exactly where they want it. And we see this in the older videos from the 80s, the borderline videos of Eric Dollard's coils. So that was the true Tesla coil, is a space, because you get capacitance between each winding. But that's not the case here, because we got to pack it in. We got to add 200 pounds per horsepower output, which means we don't get to space the windings. It's not going to be a true Tesla coil. It's just going to be a very interesting other Tesla coil, Tesla B coil, that we've never heard of before. So the laminates are at right angles. It could be the formation of a, what do you call it? Oh no, wait a minute. Of a transformer. You know, in one of the patents of Tesla, he used iron shielding between the primary and the secondary of his transformer, and he used iron wire as his core material, and then he had a copper winding on top of that, so he layered them, a shell, like shells of a nugget. So you got your iron nugget on the inside, and then you create a copper shell around that. That's your, oh God, what was that? Was that the secondary or the primary? Let's say it was the primary, because I can't remember. And then a shell of iron windings on top of that, and then another wrap of copper windings on top of that, which was, I guess, the secondary. And so by varying the width of the iron shell between the secondary and the primary, you could create a time lag, vary the time lag between the primary and the secondary, and then monkey with the phase relation. You could monkey with the phase relation and create various anomalies. And people have talked about creating a monkeying with the phase relation somehow, to create an over-unity device that could power itself. Well, according to the Meter Man's Handbook from 1912, center of load, they called it something else, but I equated it to William Lyne's center of load, is reached when the phase relation between the voltage and the amperage portions of the AC sine wave are 60 degrees out of alignment with each other, and I forget which leads and which follows. But it was 60 degrees. And does that imply, then, that the context of that discussion was three-phase power? Because if you had anything else, let's say if it was just single-phase power, then it should be 180 degrees out of phase. In other words, half a wavelength. It could be. That might be why the 60 degrees was significant. It could be simply that it's half a wavelength. Which makes sense, because then the voltage and the amperage cancel out. And you would get a stationary rotating aluminum disc in your watt-hour meter. Cowabunga, I never thought of that before. Pays to put my mug in front of the cell phone and start talking, because I'll never know what I'll come up with once I start gabbing. Get more mileage, more bang for my buck. Okay. So we're dealing with 180 degrees out of phase. We have to get, if it's a DC, we have to get the magnetic field and the electric field to be 180 degrees out of phase. You wouldn't think of them being out of phase, right? But they are, because you turned on the circuit. And that's the beginning of a wave right there. And when you turn it off, that's the terminus. No, that's the start of another wave. In a sense, it's like the reciprocal. It's like the ghost image. It's another wave. It implies it, which is the same as being another wave, because you get a voltage spike no matter what you do, whether you turn the circuit off or turn it off. So you get two waves every time you turn a circuit on and off, a DC circuit. And the second one, when you turn it off, is implied. In counter space, of course. It had to go somewhere. The voltage spike energy had to go somewhere, so it went into counter space. So it's not implied, it's real. Well, it's imaginary. According to Eric Dollard. Okay. Oh, I love this. That's why we say it's implied. Implied in space. By being in counter space. Cool, I love it. So you get the definition of your wave right there when you turn the circuit on and when you turn it off. So where's the half point, if you don't know where that is? Well, you know what? The parameters of a wave are probably predicated on something different. Obviously not the way an AC circuit is predicated on. Because it's not defined. We don't define what it is. We don't define it based on when things turn on and off, or reverse polarity for that matter, if you prefer. Probably instead by some other parameters, but it is defined. So all we have to do is discover what those parameters are. It may be the geometry of the device, the windings. It may be the geometry of the windings that defines with the wave. Well, yeah, the length, the winding on the coil, duh, you know. So, okay, that'll do. So now we've got our half wave based on the wavelength, the length of the wire. So we're not trying to create a winding as it would be in an AC situation to match the quarter wavelength of the AC frequency that we're running through the system, because we're creating the frequency by the length of the wire. And the half point of the wavelength will be the half length of the wire. And that's how much displacement we have to shift the magnetic field apart from the electric field. Good luck is what I'm thinking. With a long wavelength, how do you do that? Oh my God. Well, maybe if you make the winding out of iron. You know, the only other person I can think of who might have used, well, who did use iron in his windings was Nathan Stubblefield. According to John Bedini on his website, the patents, actually, according to the patents, he would combine copper windings. The design of his, it almost looked like a transformer, basically. He combined the copper windings with iron windings in his own configuration. Yeah, I always assumed in my very earlier YouTube videos, in which I was postulating the LMD, Eric Dollard LMD, I made note of the fact that there was cotton sleeves wrapped around along the length of the copper wire used in those patents, and so I presumed that the cotton sleeve was soaked in a resinous, waxy, whatever insulating medium, which served as an insulator for the copper windings and a dielectrical material separating the copper from the iron. You know, not stated in the patent, but kind of implied that it could be there, because the cotton is already a dielectrical insulator of sorts. Why not improve it, you know? Why not improve it? So, Nathan Stubblefield used iron wire in combination with copper. So that could, and he lived in the same time frame, in the same, what do we call him? Generation as Nikola Tesla. He might have been a little older, I can't remember. Yeah, he might have been a little older, a little earlier time frame. So what if the core is pure aluminum, just like William Lyne said it and Paul Scarzo were alluding to, that aluminum can replace iron. So now aluminum is the core, pure aluminum. And the winding is copper and iron alongside each other. Or configured in a certain way. Holy shit. What if we have to study Nathan Stubblefield's patents again? The one on the, what's it called? The Earth battery. It's the Earth battery patent, which doesn't look like an Earth battery. It looks like a transformer cord. And he buried them in the roots, among the roots of an old oak tree, and waited a year. Yeah, because the iron had to oxidize. You know? The roots of the tree had to get in there and attack it and connect with it, because the tree is a grounded antenna device, which is a very interesting concept in itself. Because now, if that's your earth battery, it's communicating. What if we did something along those lines of a Nathan Stubblefield earth battery? Maybe that's the missing key, along with the aluminum core to this coil. Because Nathan Stubblefield, he used an iron bolt as his core. So what if we take the earth battery and substitute an aluminum core for that iron bolt core, but keep the same design, and add in the resin-coated cotton sleeve along the copper wire, using the mixture that Mark McKay tells us that was Tesla's favorite, pine rosin, beeswax, and 5% carnauba wax. So I'm assuming a 47.5 blend of beeswax versus pine rosin, not knowing any differently. It could be. Didn't Nathan Stubblefield get clear reception up to, 20 some odd miles, 25 miles? Of course, in those days, there were no power stations sending AC current through the earth to muddy the situation, as somebody makes note of, who was analyzing the, I guess it was John Bedini's website, analyzing the Nathan Stubblefield patent. But he did try out, and he said he duplicated it. So we have no videos, but he said he duplicated it. So what if that's the secret to Tesla's special generator, is that it's a Nathan Stubblefield so-called earth battery, which is really a kind of a DC transformer, in which we substitute aluminum for the core, take out the iron bolt of the Nathan Stubblefield's version, and put in aluminum for the core. And now we're not just adding iron, we're adding copper to the windings, because it's a mix. But the more windings we add at all implies still the more iron we add to the system. Now, there's a fellow in Pennsylvania, Philadelphia, I think, I forget his name, who's a genius, and his core is not solid iron. He discovered if he uses an iron shell, using an iron pipe for his shell, and then cut a slot down the length of that iron pipe to reduce eddy currents in that iron pipe, he magnified his results. So, and you know what that looks like? That looks like my design for my, if you can see it there, you can't see it, it's way behind there. My version, my attempt at replicating the so-called P gun, in which I put a slit down the, what's it called, the paper layer, the non-conductive layer of a orgone wrapping. No, I put the slit down the metal, the conductive wrapping. I put a slit down the length of the conductive wrapping, which corresponds with the slit of this pipe core. So you get an air core, in a sense, to this pipe, but it's an iron shell, but with a slit down one side. Funny he didn't put 2 or more slits. I used one slit. Oh, I remember now. And then I alternated layers, and the slits were on opposite sides, 180 degrees apart. And we are trying to create 180 degrees phase relation between the magnetic field and the electric field. So maybe that's how we're supposed to make the core, is an orgone wrapping, alternate layer of iron and, well, no, in this case it's aluminum. Aluminum and resin, let's say. The resinous mixture made from natural sources, not petroleum, which is not natural. I mean, it's not organic, even though we claim it's organic. No, it's not. It doesn't come from a plant. or an animal. It comes from the earth. Iron oxide, calcium carbonate, and high pressure and high temperature over time can create all of the petroleum and methane gas. It does not come from a plant. So we've got, oh, well that could be aluminum foil. And you shape it, and then I was using rosin paper from the hardware store, and I used natural shellac to paint it. So I didn't know about Mark Buquet's recipe, quoted from Tesla's recipe yet. Or no, I did. I just came up with my own. No, it was strictly intuitive, I think. Well, no, that recording was 2012. I might have heard about it already. And simply went for what was available. I didn't want to make it, the raw materials. I just wanted to construct it. So I took natural shellac from the shellac tree that comes from India. And I knew that came from a plant. It was a tree resin, you know. That was my substitute for pine rosin. So, and rosin paper is imbued with the extract from rosin, I believe. That's by definition the constituency of a rosin, the making of a rosin paper. They're red. It's red colored rosin paper. So we could layer. We could make an orgone wrapping on the inside. I bet that would boost it even more. And then we'd have the slit down the aluminum sheath or layer, and alternate that every other side, 180 degrees, every other side of the round geometry of this. So we're making a new core, and it's an orgone wrapping core, because we're using aluminum, because you can get mylar insulation like insulation that's aluminum sandwich on either side with plastic, and it's got nylon fishing wire kind of crisscrossing, checkerboard crisscrossing to reinforce it, and it's flat. It's relatively flat, so it doesn't take up much thickness. And then you got the rosin paper with coated with shellac, natural shellac on either side. That's not too much thickness, and that goes entirely around the circumference, the girth of this orgone-wrapped aluminum core. So this is a very different geometry of how to make a coil winding. How we use this coil winding is still up for grabs. You know, these are all, we're working our way from the outside in, from the general to the particular. Details coming in last. Because that's the only way I can operate intuitively is, you know, start vague, and you're not going to start vague on the details. That would be a waste of time. You wouldn't know what you're doing. So you start vague on the general overview. At least then you get a semblance of a hierarchy of greater and greater knowledge that makes sense, instead of trying to start with the details. Forget that. It's not going to work. If you're trying to work from inspiration and imagination and intuition, forget it. It's not going to happen. So we start with the generalities, and the details are the last things that fall into place. If we construct this strictly from what if, completely hypothetical, because we have so few clues to work from. But we have some. And they work their way in as we layer in the details to this, layer by layer. We see if we can work them in, because then it shows, and at least we're consistent with the storyline. Okay, so we don't know what to use these coils for, other than could be a transformer. Well, William Lyne said there was a reciprocating piston, and I thought that was aluminum, and now it doesn't matter, maybe, possibly, unless we go for more traditional materials, iron, ferromagnetic, or a permanent magnet. What if the reciprocating piston is a permanent magnet, and we just have traditional pickup coils, copper wand pickup coils surrounding that, and then it's an alternating, because it's reciprocating, it can be an alternating generator, an AC generator, and it's electrostatic field, now that we know, Hutchinson effect, because we're flushing it with compressed air to prevent arcing. So we know we can devise Hutchinson effect in that generator, but now we pass it through either a singular or a series of transformers that will transform the nature of the energy that's going through there, because it's going to be a very uniquely constructed or designed, transformer, in which orgone-wrapped aluminum core and a copper and iron bifilar winding. Wait a minute, no, if this is a transformer, the core is orgone aluminum wrapped, and the displacement, time lag displacement between the primary and the secondary is similar construction. You know what that means? No, what does that mean? It's not bifilar. That means the primary is copper and the secondary is iron, or the other way around? Ooh, how elusive is that? This is where the Schill approach, the patent... Oh, I gotta roll over. The Schill approach is significant because... Why? Oh, God, I just had the thought and I lost it. See, normally when we think of a transformer, we have the primary maybe is over on the left side, and the secondary is on the right side, and the iron core connects the two. But Tesla, when he created his time lag, didn't do that for a very specific reason. Dear. Well, now the iron hull of the Electra U-boat has no factor whatsoever in this, because it's strictly in the windings. But which is the primary and which is... What does it matter? Well, it does matter, because... Okay. I would have to take a guess that the primary is the iron winding and the secondary is the copper. And if we want more power to the system, we're adding more windings to the primary. Which means it's a step-down transformer. Wait a minute. Oh, wait a minute. It's a long winding, right? That means it's a long wavelength. It's not going to be your normal 60 cycles, but it's a step-down transformer. Which means what? Which way, see, I don't remember which way step-down works. Are we stepping down the voltage? That means we're increasing the amperage, which is perfect. That means the secondary has to be copper, because we're picking up the amperage is going to go to the load. So the primary is iron, and when we add more windings, not only are we making a longer wavelength, but we're increasing the factor of step-down voltage, which means we're increasing the buildup of amperage. If I have it right, unless I have my step-down, step-up backwards, we're improving the amperage, and we're working from a more stable base because we have a much longer wavelength, because it's going to be voltage that we're going to be creating in this device, not amperage, but then we convert it into amperage. But it's voltage that we're creating, and that makes sense because Tesla didn't he work with low amperage, high voltage circuits? But this is low frequency. This is completely opposite to what we've been taught. Oh, he always worked with high frequency, and that's how he created his radiant energy. But here, he's got his special generator with his tri-metal substances, and it's completely opposite. It's a low frequency generator. No, wait a minute. If that's the case, then the reciprocating piston is very slow acting. William Lyne was not implying that. He was implying, and And I kind of went along with it because we're taught that way, to think that Tesla always worked that way. But what if Tesla was a man who figured out all the limits of his subject matter? And so if he went to the high end, you'd think he'd go to the low, but who's ever bothered to think that he went to the low end? William Lyne said it, though it's low. So he mixes up elements in his speculation, because it is speculation. He alluded to that in one of his emails to me, that he doesn't know. He's just speculating. So it's a low frequency generation of power at its primary from the kinetic side, which could be a reciprocating piston, but it'll be like a steam engine. It'll be very slow. Woo! Only now, instead of steam driven, it's compressed air. Hey, not much different, you know? But it flushes through and creates prevents the arcing and creates the Hutchinson effect inside the primary. Do we call that the primary mover? No. The primary area where the power is being initially generated before it gets transformed. In his special transformer, it almost doesn't matter to call it. Well, it is a special generator because it's a Hutchinson effect. You've got a wave, a reciprocating piston, in the midst of an electrostatic field, which is prevented from arcing because of the compressed air that's flowing through here that's running it. So it makes sense. It makes perfect sense. And we don't have to worry about the magnetic field lagging or leading the electric field, because now we're dealing with an AC situation. So now we've got the voltage component of the sine wave and the... well, it's not a sine wave, is it? No, because it's not circular. Ooh. What kind of wave is that? A square wave or a double square wave? I think, it's a square wave, because no, wait a minute. No, it's a pulse. It's a pulse wave. It's pulses. It's a pulse generator. Because every time the reciprocating piston reverses direction, that's a pulse. And the pulse, it's an AC sine wave skewed into pulses. So you get your peaks and your troughs are now not nice curves. They're sharp spikes. So we're getting voltage spikes now coming out of this thing. And one spike is above the median and the other is pointing down below the median in the opposite direction. Whoa, talk about... this is not an environment I would want to live or have small children in in an electro U-boat in a time of war. You wouldn't want small children because their stem cells would get so confused it would give them cancer, big time. And the U-boat people would probably come down with cancer later on anyway, if they were not shielded from the AC field created by this device, because it would be uncanny what it would do to screw up the voltage mapping, because the physiology wouldn't be able to handle those sudden AC spikes, accentuated AC spikes. We're not just talking about the voltage spikes that are inside the AC line as it flips polarity. We're talking about magnified spikes, nothing but spikes, no sine wave component going along with the spike. That's a pretty unhealthy environment. Anywho, powerful. His special generator kept miles away from any human habitation, hopefully, and buried underground to shield it, hopefully. So we've got this reciprocating piston run by compressed air in an electrostatic field, flushed with compressed air to prevent arcing. And it's a slow reciprocation, though. Which means what? It implies it could be a very long shaft. Oh, wait a minute, we're back to aluminum now. No. I said it was going to be iron surrounded by a copper winding to pick it up. Oh, that's right. Well, you know, no. No, your aluminum, here's your aluminum core. Is a very long aluminum piston. And you've got your iron combined with copper winding, except the interior winding is your first layer is iron winding, followed by, oh no, these are not aluminum rods, they're aluminum pipes or shells, you know, with the slit down the length. You forget about the orgone wrapping. No, we've got two of them. No way. And they're reciprocating in opposite directions over time. And one is the primary and the other is the layer between the primary winding and the secondary winding. The primary winding is iron and the secondary winding is copper. Whoa, this is getting to be weird. And so we have our aluminum delay between the two, the layered delay. No, this is ridiculous. The aluminum shell layer would be too wide. Unless that's the chassis. Yeah, it doesn't move. So we only have one piston that moves, and it's at the core. And it may not be solid. It could be hollow with a slit down the length. I don't know about this. This doesn't look right. No, it doesn't. You know why? Oh, no. No, wait a minute. If we're doing the step-down idea, no, it does look right. Oh. Oh, so that means the copper wire is a different gauge. So it's starting to look like a redesign of the watt-hour meter, because the voltage coil is made out of iron. That's the primary. And it's thin wire, and it's many turns, right? And then we've got an aluminum layer, shielding, surrounding that. And then we have the copper winding, which is just a few turns of very stout gauge. And that's going to be the step-down transformer circuit as well as the construction of the winding. It's both. It's all wrapped up in both. So this device becomes the circuit. It's the geometry of the device and the schematic of the circuit are like one and the same, practically, because it's all wrapped up in one thingy. And then we have our two inlet ports, or one inlet, one outlet, the one-way valves without moving parts to flush air through the system in one direction. Which, again, we could change this into a DC device, a homopolar disc device, in which we have a stack of aluminum discs with air spaces between them. It's a Tesla turbine, and instead of a reciprocating piston, which actually makes more sense now that I think of it. But it's DC now instead of AC. That's the difference. So we get two versions to this. We can have a DC version and an AC version based on the structure of the piston itself. Is it a reciprocating piston, or is it a stack of rotating aluminum discs? There you go. Hui. So the orgone wrapping is out the window. But the insulation on the wire could be orgone in itself, because it's a special mixture of, pine rosin and beeswax and 5% carnauba wax. That already sounds like an orgone wrapping in a sense. And that's as good as it gets, and that's good enough. Possibly that's good enough. Unless, if we go back to the video that I was shown of the YouTube video of how pole transformers are made, they actually use an aluminum core. They do not use an iron core. In fact, there's no iron in those transformers, now that I think of it. It's copper wound aluminum core, and the aluminum core is a laminate, just like you would make a laminate core for an iron laminate core to an or a transformer. The pole transformers are aluminum cored, and they're laminate with paper. Oh my goodness. There's our orgone wrapping all over again. Huh? Oh, in the layer between the primary and the secondary, we can use that. It would be an aluminum laminate with, could go back to rosin paper. No. Yeah, rosin paper shellacked, though, this time, with pine rosin, beeswax, and carnauba wax. There you go. Okay. So we've got a generator and a transformer with a time lag built in. And we've got a step-down transformer built in. And it's either AC or DC. Wow. And it's in the Hutchinson effect that magnifies the power gain. Well, in addition to all these other features that are magnifying the power gain. Gewalt. If that ain't a full-fledged design, I don't know what is. Okay, I don't think I can come up with anything more. Oh, and I'm only another hour? What are these, hour-long videos? My goodness.